Now it's time to look at greatest common factor. Greatest common factors. We've talked about LCM, or least common multiple, in previous videos. Now we're going to look at the greatest common factor. So our learning target today, I can apply the greatest common factor. All right, so first of all, probably need to define some words there. And let's talk about factor. Well, a factor is a number that divides into another number. No remainders though, so it divides evenly with no remainders. Okay, so it can divide into it. You can look at it as multiplication as well, a number that multiplies another number to get a product. You can look at it that way, but I like to think of it as division, a number that divides into another number with no remainders. So for instance, the factors of 20. I'm looking for all of the numbers that will divide into 20 evenly. Or, like I said with multiplication, you can think of all the numbers that you can multiply together that will give me 20. So I know that 1 times 20 gives me 20. So 1 is a factor, 20 is a factor. I know that 2 times 10 will get me 20. So that makes 2 a factor. That also makes 10 a factor. 3 is not a factor. 4 is, though. I know that 4 times 5 is a factor. And in fact, I'm back up to where I am there. So that's the list of all my factors. I'm going to rewrite it neater. 1, 2, 4, 5, 10, and 20. Those are all my factors of 20. I could take 20 and divide it by any one of these, and I will get an answer with no remainders. Okay. Well, common factors just mean the factors that 2 or more numbers share. Okay, so we list the factors of 2 different numbers, and then we look at all the ones they have in common. So let's try that. Common factors of 9 and 12. All right, so I'm going to list all the factors of 9. They are 1 and 9, and then, well, 3. That's it. Those are all the factors of 9. Okay, easy enough. The factors of 12, 1, 12, 2, 6, 3, and 4. Okay. All of those. So here are all the factors for 9. Here are all the factors for 12. And then if I'm looking at what they have in common, and I can say, well, they have a 1 in common, and they have a 3 in common. That's what they share. Those are the common factors. Now, that leads us to the greatest common factor. Well, that's the largest of those factors that 2 or more numbers share. So if we went back to this one, we'd say, well, they shared a 1 and they shared a 3. The largest of those is a 3. So the greatest common factor of 9 and 12 is 3. Okay, the greatest common factor that 2 or more numbers share. Now there's several ways to get this GCF that we call it, greatest common factor, or we sometimes refer to it as GCF. And one way is to do a list just like we just did. So let's try that. We'll do a list for 12, and we'll do a list for 18. All right, so we're going to say all the factors of 12. Well, I know 1 times 12. I can always start there. And then I just kind of start working my way up. I look at 2. Well, can 2 go into 12? Yep, it sure can. It goes into it 6 times. Can 3 go into 12? It sure does, times 4. And nothing else goes into 12. So there's all my factors. Let's do 18. 1 times 18. 2 times 9. 3 times 6. And then 4 doesn't go into 18. 5 doesn't go into 18. And then I'm back up to 6, which I already have taken care of. So I know I'm done at that point. So I've listed all the factors of 18. Now, common factors, 1, 2, 3, and 6. Those are all the ones in common. But greatest common factor is the largest of those, which is that one. So that tells me that my GCF is 6. The greatest common factor of 12 and 18 is 6. And here's what this means. 6 is the largest number that will divide 12 and 18 evenly with no remainders. 6 is the biggest number that will divide 12 and divide 18. And if I was dividing up groups in classes, and I had one class of 12 and one class of 18, and I wanted groups to be of equal size, then I would make all of the groups 6, and I wanted them to be the biggest groups possible. I'd make them out of 6, because 6 will divide 12 and 6 will divide 18. It's the greatest number that will divide 12 and 18. You hear me repeating that over and over again, but a big part of this is making sure that you really understand what the GCF means. Not that you can just find a number, but now that you understand what does that say. We know it, but what does it mean? Okay? And the greatest common factor tells me that 6 is the largest number that will divide 12, and it's the largest number that will divide 18 evenly together, if I was doing that. All right, now let's try a different GCF method. Okay, so the list will work. The downfall of the list is that sometimes the numbers are large and you forget one of the factors. Maybe you don't know all of the numbers that multiply together to give you 84, and you miss one. Well, you might have missed the most important one. So you might need another method. So we're going to try it with the factor tree, prime factorization. So I'm going to do 20. Okay, well, I know that 20, I can do 2 times 10. 2 is prime, circle. And I can do 5 times 2, circle. So that's 2 times 2 times 5. And let's go over here and do 36. Let's see, I'm going to do 3 and 12, prime. 4 and 3, prime. 2 and 2, prime. So that's 2 times 2 times 3 times 3. Now I'm actually going to do very similar to what we did with LCM. I'm going to make this Venn diagram here. Here's 20, here's 36. And I'm going to do exactly like I did with LCM. I'm going to place these numbers where they go. If they share a factor, I'll put it in the middle. If it's a factor that is unique to that number, I'll put it over here. So I see a 2 here and a 2 here. So I'm going to put a 2 there. I see a 2 here and a 2 here. So I'm going to cross that out. I'm going to put a 2 there. And then this 5, there's no 5s over here, so it goes here. And then 3s, they both go over here. Now when we did LCM, we took all of these numbers and multiplied them. Okay, but GCF is different. For GCF, we're only multiplying what's in the middle. We're only multiplying what they share. So in this case, they share the common factors of 2. So 2 times 2 is 4. And so guess what? The GCF is 4. That's it. Factor tree. Place them in your Venn so that you can see what they share and what they don't share. And then for GCF, you multiply what they share. If this was LCM, we would have done all of these numbers multiplied together. Well, just like LCM, you could also use the birthday cake method. So let's try this. Okay, let's say I have 30 and 48. Reverse division. I'm going to start with 2. And I'm going to go 30 divided by 2 is 15. 48 divided by 2 is 24. Then I think we can divide 15 and 24. And I'm thinking a 3. 15 divided by 3 is 5. 24 divided by 3 is 8. Nothing other than 1 will divide 5 and 8, so I'm done. Now, for LCM, when we did LCM, you took the 2 times the 3 times the 5 times the 8. Okay, hopefully you remember doing that. However, we're not doing LCM. We're doing GCF. So for GCF, we're only taking the numbers down the side and multiplying them. GCF, we're only taking these numbers down the side. And if you don't have a highlighter there, we'll circle those numbers. So I'm going to do 2 times 3, which is 6, and that tells me that the GCF is 6. Now what I'm going to do here is I'm going to use all 3 methods to show you that you get the exact same answer. Okay? I want you to do the same thing. One more practice with all 3 methods. So we're going to try a list. So I know 1 times 24, 2 times 12, 3 times 8, 4 times 6. Okay, several factors for 24. But that's all the numbers that will divide into 24 evenly with no remainders. Okay, let's go and do 40. 1 and 40, 2 and 20, 3 doesn't work, 4 will work, 4 and 10, and then 5 and 8. Okay, there's all the factors for 40. And then I'm looking for what's the largest one that they share. It appears to be 8. So I'm assuming that the GCF here is 8. Well, let's see if I get the same answer if I do it with a factor tree. 2 and 12, 6 and 2, 2 and 3. So that's 2 times 2 times 2 times 3. And then 40, come over here, leave myself room for a VIN. 2 and 20, 10 and 2, 5 and 2. 2 times 2 times 2 times 5. Here's my VIN. 24, 40. Now I can see what they share. I see a 2 there, I see a 2 there, put a 2. 2 there, and a 2 there. There's another 2. 2, 2, there's another 2. The 3 they don't share, the 5 they don't share. So, since I am worried only about what they share, then I look at what's in the middle. So this is all that I will multiply right there, what's in the middle. So I'll do 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Got the same answer. Birthday cake, 24, 40. Start with 2, 12, 20. Can divide by 2 again. They're both even, so I know 2 works. 12 divided by 2, 6. 20 divided by 2, 10. I can divide by 2 again. 10 divided by 2 is 5. 6 divided by 2 is 3. And then, since we're doing GCF, all I'm concerned about is what's down here along the side. And we see that actually we're ended up with something very similar. We've got 2 times 2 times 2, which is 8. So I ended up with the exact same answer. What this means is that 8 is the largest number that will divide both 24 and 40. 8 is the largest number that will divide 24 and 40. Right, well, now the GCF comes in handy sometimes when we're looking at the distributive property. Now hopefully you have heard of the distributive property, but if not, essentially it is a property that allows for you to distribute a number through multiplication across the addition. So here's an example using letters. And I know that may seem odd to you, but if you'll notice this A over here, I took this A and I multiplied it by the B. and then I took this A and I multiplied it by the C. And I added the two answers together. And the distributive property says this side and this side are the exact same thing. Over here, I could add B plus C and then multiply it by A. Or I could do it this way, A times B plus A times C. Now if you don't like letters, let's try this with numbers. Here, this is saying if I wanted to, I could add this together. 8 times 3 gets me 24. Okay? Or distributive property says I can take the 3 times the 5 and the 3 times the 3. There, add the two together. 15 plus 9, 24. I get the same answer. And if you're sitting there thinking, well, why would you do the version on the right side? Because that's so much more work. I want you to remember that 6th grade, we're very much just starting the introduction to the distributive property. We really just need you to understand the process for it. Later in 7th and 8th grade and high school math classes, you will find that the distributive property is very useful and very needed, and you just need to have a basic understanding of it at this point. You know, I agree, for a problem like this, you wouldn't want to go to this amount of work. But right now, we're just working on the property, how to illustrate the property. So let's try this with something like 36 plus 50. Well, wait a second. This doesn't look like back here, does it? I'm missing some stuff. Well, that's where the GCF comes into play. I'm going to use the GCF to pull out a number and make it look like the other. So I need to find the greatest common factor of 36 and 50. So I'm going to use birthday cake or ladder. I'm going to divide by 2. This becomes 18, and this becomes 25. And you know what? There's nothing other than 1 that will divide 18 and 25. So my GCF is just 2. So here's how I'm going to do that. The 2 is what's going to be out here. What's in parentheses is going to be 36 divided by 2, which is 18, plus 50 divided by 2, which is 25. And there it is. And by the way, if you're noticing a shortcut, you may have noticed those numbers and those numbers ended up being the same when I was using the ladder method. I'm going to show you this one more time, and we'll do more with this in class, I promise. Okay? So I want to find the GCF of these two numbers so that I can pull out that number. Okay? I want to find the largest number that will allow 50 and 25. So ladder or birthday cake, I'm going to do 5. That's going to be 10, and this is going to be 5, but I can still go a little further, can't I? So I'm going to go again. This is 2, and this is 1. I can't go any further. So GCF says multiply these two. 5 times 5 is 25. So the GCF is 25. So I'm going to go over here and I'm going to put the 25 outside the parentheses. And then I'm going to say, okay, what's 50 divided by 25? Well, it's 2. Plus, what's 25 divided by 25? 1. Close the parentheses. And there is the distributive property illustrated using GCF. And if you noticed again, look at those two things right there, how they ended up the same. All right, your turn. See if you can do these problems. Bring them in tomorrow. We'll talk about them, and we'll work a little bit further on this, and I will see you then.